Okay, so now we're going to be looking at graphs, and we're asked to identify, are these graphs functions? So continuing on what we talked about yesterday. So a function is a special kind of relation where every input has exactly one output. And what that looks like on a graph, each input, each x, can only have one y. So we use what's called the vertical line test to tell if a graph is a function or not. So what that means is if I draw a vertical line anywhere on the graph, if it touches the graph more than once, then it's not a function. So right here on this graph, you see I drew a vertical line. It intersects the graph in two positions. Therefore, I know this is not a function. The next one, if I drew a line right here, vertical line, it would intersect the graph more than once. So that's not a function. On the next one, if I drew vertical lines, I could never draw a vertical line that touches the graph more than once. Therefore, this is a function. And then here, any vertical line I draw is only going to intersect the graph once. So it is also a function. So you can think about the function has some rule it's assigned to it. So in this case, our rule is 3x minus 2. So whatever we put into the function is going to be multiplied by 3 and then subtracted by 2. We're getting to choose what the input value is. So our input is independent because it doesn't matter. We can choose whatever we want to plug in. But what we get out depends on what we put in. So the y value, the value you get in the end, is the dependent variable. And so they just want to reiterate that here on a graph. The x-axis is sometimes called the independent axis, or it's got independent variables. The y-axis is our dependent variables. So that's mainly for the word question you're going to get to make sure you know the difference between independent and dependent. Okay, so we're told here to find the domain and range for each of our 5 functions. So we start here with this relation. So it gives me 4 ordered pairs. So the domain is just the set of all x values that are used. So my domain here, I use -3, I use 4, and I use 5. So that would be my domain. Don't ever repeat a number in the domain. So even though -3 occurs twice, we only list it once. Also, make sure when you list the domain and the range, we like to put them in order from least to greatest. So if it's just a list like this, always go from the smallest value to the largest value. Okay, next we are going to find the range. So the range is the list of y values. So I've got 1, 2, and 6. Okay, the next one, my function is defined a little differently. It says my function is the set of all x's and y's such that y is equal to 4. So this is just the equation of a line. And remember, this is one of our special cases. When you have y equals a number, that is a horizontal line. So I go to where y is 4, I plot my point, and my line is going to be horizontal, like this. Okay, so now what's the domain? What's the list of all possible x values? Well, again, we're walking along the graph. The x's go on forever. So the smallest x value is -infinity. The greatest x value is +infinity. Another way you could say that is all real numbers for my domain. Now the range is the list of y values. Yeah, there's only one y value. It's 4. It's never lower than 4. It's never higher than 4. It's always 4. So my range here would just be the set containing 4. Okay, now we've got y equals x squared. So you should know what this graph looks like, but maybe you don't. So if you don't know what the graph looks like, it's always a good idea to plug in some values. So I'm going to plug in -2, -1, 0, 1, and 2 to find out what the y values are that correspond with that. If I plugged in -2 for x, -2 squared gives 4. -1 squared gives 1. 0 squared gives 0, 1 squared gives 1, 2 squared gives 4. So now I'm going to plot those points. Okay, so what's the shape of my graph? It's a parabola. Right? Those are not all the x values. Those are just some of the x values that I plugged in. I know that this graph continues in that pattern forever. So what is my domain, my list of x values? Well, the smallest x value, if I start over here, I can't get left enough. So it goes forever, negative infinity, and then the greatest x value is positive infinity. It never stops along the x-axis. Now let's find the range. So the range is the list of y values. So what is the smallest y value that the graph takes on? Well, it doesn't get any smaller than 0. So 0 should be included. So I put a bracket. And then the highest possible y value is positive infinity. It never stops growing in the y direction.
0 isn't included?
E is included. I put a bracket. Okay, so right here I've got some problems to find the domain. So say I want to know what all x values can I plug in. Well, this time x is underneath the radical. So this is going to be one of my two rules where my domain is not all real numbers. Because we're not allowed to take a square root of a negative number. So what we would do is we would say, okay, well, what's underneath the square root can't be negative. So how do we say that? If something can't be negative, we say it must be greater than or equal to 0. That's the same thing as cannot be negative. So now I can solve to see what x values make this inequality true. So you add 4, you get x is greater than or equal to positive 4. So my x values that I'm allowed to plug in must be bigger than or equal to 4. So we're going to pick some x values that fit that criteria. Say 4, 5, 8, 13. Okay, what happens if I plug those in? So if I plugged in 4, remember there's a square root here that I've circled, you can barely see. The square root of 4 minus 4 is the square root of 0, which gives 0. If you plug in 5, 5 minus 4 is 1. The square root of 1 is 1. If you plug in 8, the square root of 8 minus 4, that's the square root of 4, which gives 2. Wow, that worked out nice. And 13, if you plug in 13 minus 4 is 9. The square root of 9 is 3. Okay, so I'm going to plot these points. I've got the first point is at 4, 0. The next one is at 5, 1, 8, 2, 13, 3. So you can kind of get an idea of what this graph is doing. Maybe some of you already knew this. Maybe you didn't. You will next chapter. So that's what a square root graph looks like. So now what is my domain? What's the list of possible x values? Well, again, we couldn't plug in anything that was less than 4. So my smallest x value that worked was 4. And that's included. What's the greatest x value? Well, the graph continues in the right direction forever, so it's positive infinity. Next, we look at the range. What is the lowest y value the graph takes on? 0. It never gets lower than 0. And then the highest y value the graph takes on. Well, it's growing slowly, but it is continuing to grow upwards. So it would go up forever to positive infinity. Now we've got x is equal to y squared. Well, that's not a very good, it's not a very good graph.
It was just radical.
No. So if you wanted to solve for y, it would be plus or minus the square root of x. Because you chose to take a square root, and you always have to count for the plus and minus. I think I've mentioned that before.
That's kind of sucky.
So we're just going to leave it like it is. Since x is by itself, we're going to treat x as our dependent variable. And we're going to let y be the independent variable, which means we're going to choose some y's. -2, -1, 0, 1, and 2. Now what happens when I plug those y's in? What do I get for x? You plug in -2, square it, you get 4. You plug in -1 and square it, you get 1. You plug in 0 and square it, you get 0. You plug in 1 and square it, 1. You plug in 2 and square it, 4. So what's this graph look like? 4, -2,
It looks like
1, -1, 0, 0, 1, 1, 4, 2.
that's not a function.
It is not a function. It's definitely not a function. Okay, but we can still identify the domain and range. The domain, what x values does the graph take on? Well, it's never going to go over here. It doesn't start until we get to 0. And then it continues to the right forever to positive infinity. Now the range is the list of y values. So the graph continues forever and it's going down. So the lowest y value is negative infinity. And the graph climbs, climbs, and then it's still climbing. So it goes all the way up to positive infinity. Okay, so we get two functions. We get f, which is defined as follows, and g, which is defined as follows. And we're told to find each of the following values. So first we want to find the function f evaluated at 2. So what is the y value when x is 2? Well, we'll go to the function f. When x is 2, the y value is 6. So the function evaluated at 2 is 6. Next, we've got g evaluated at 4. So now we're plugging in 4 for x. So g of 4 would give 3 times 4 plus 5. So that would be 12 plus 5, which is 17. Now the next one wants to know, what is x if f of x was 8? So what is f of x the same thing as? That's the same thing as y. So what would the x value have to be if the y value was 8? So we're looking at the function f. When the y value is 8, the x value has to be 3. And the next one wants to know, what is x if g of x is 26? So again, g of x is just the y value, be 26. So we know g of x is the equivalent to 26, must be equal to 3x plus 5. And then we're going to solve for x. So 21 equals 3x, which means x is equal to 7. Next, we want to know, what is f evaluated at 3 minus g evaluated at 3? Okay, so first, let's find what f evaluated at 3 is. We go to the function f. When the x value is 3, the y value is 8. We're going to subtract g evaluated at 3. So we plug in 3 here for x. So 3 times 3 is 9. 9 plus 5 is 14. 8 minus 14 gives negative 6. Okay, so the next one seems to confuse people, but it really shouldn't. Okay, now we want to know, what is g evaluated at a? So now we're going to plug in a for x. So g of a is equal to 3 times a plus 5. That's it. You're substituting a in for x. All you're doing is changing the variable. The next one's a little bit trickier. We're going to substitute a minus 2 in for x. So g of a minus 2 would be equal to 3 times a minus 2 plus 5. Now you're going to have to distribute. So that would give 3a minus 6 plus 5, which is 3a minus 1. So g of a minus 2 is equal to 3a minus 1. We're finding the average rate of change, and then we're going to use what's called the difference quotient. We can find the average rate of change of any function, linear or not. So depreciation of a Mustang. If a new Mustang is valued at $20,000 and 5 years later it's valued at $8,000, what is the average rate of change of its value during those 5 years? So we can see between these 2 points, it's not linear. Okay, the car loses a lot of value initially, and then it starts losing less value and less value. That's not a line. But we can still find the average between the two by finding the slope of a line through those 2 points. Okay, so we would use the slope formula. So my y value is 20. My y values are 20 and 8. So y2 minus y1 is 20 minus 8. My x values are 0 and 5. So x2 minus x1. Again, just using the slope formula. y2 minus y1 over x2 minus x1. 20 minus 8 is 12. 0 minus 5 is negative 5. So I've got negative 12 fifths, which is negative 2.4. And my y's are in thousands, so it's negative 2.4 thousand. That's approximately how much the car is losing every year. $2.4 thousand in value. Now these two are helping lead you up to the difference quotient. So we want to find what is f of x plus 1. So we're substituting in x plus 1 into x. So that should give f of x plus 1 is equal to 3 times x plus 1 squared minus x, which is x plus 1. So you have to be careful. Remember, you're subtracting all of x. So when you substitute in x plus 1, you have to be subtracting all of that. So I put in parentheses to signify that. Now I've got x plus 1 squared. So that means I want to multiply x plus 1 by itself. Then I'm going to go ahead and distribute that negative. So that's going to be negative x minus 1. Now I'm going to distribute here. So that's going to be 3 on the outside. I've got x squared plus 1x plus 1x. That's plus 2x. And then 1 times 1 is 1. Now we distribute the 3. So that gives 3x squared plus 6x plus 3 minus x minus 1. Now I want to combine my like terms. I have nothing like 3x squared. 6x minus x gives 5x. 3 minus 1 gives 2. And none of those are like terms, so I can't combine anything else. So I have found f of x plus 1. Now the next thing it wants me to do is it wants me to find what is f of x plus 1, but then we want to subtract all of f of x. Well, I already know what f of x plus 1 is. I just did all the work, so there's no reason to do all that work again. So f of x plus 1 is 3x squared plus 5x plus 2. Now I want to subtract all of f of x. So what was f of x? It was 3x squared minus x. Since I'm subtracting all of that, I need to distribute the negative. So I've got negative 3x squared plus x. So that gives me 3x squared plus 5x plus 2 minus 3x squared plus x. Now, do I have any like terms? Yes. 3x squared and negative 3x squared. That goes to 0. Now I've got 5x plus x. That gives 6x. And then plus 2. So you see how what we just did, we just found f of x plus 1 minus f of x. Well, that's leading us to the difference quotient, which has a numerator of f of x plus h minus f of x. So we're going to be doing similar things to what we just did to find the numerator, but then it's all divided by the numerator. Okay, this difference quotient is very important in calculus. It's how we find when you start talking about integrals and derivatives, because calculus is about finding slopes of things given only one point. So right now, all this is a rewritten slope formula. So if you look at this graph, we'll try to explain it. If you don't get it, you don't have to understand it, but I feel like I would be cheating you if I didn't go over it. So let's say I have any generic point. So we normally call any generic point x1, y1. If you'll remember when we did the distance formula. Remember, I had just any generic point, x1, y1, and I had another point I called x2, y2. And then we used the Pythagorean theorem to find the distance between them. Okay, they're doing the same thing here with the Pythagorean theorem, but now we're changing the names of the points. So right here, my first point is x for the x value, and then the y value is whatever you get in when you plug in x to f. So we call that f of x. Now the difference is, now we're going to move along a distance of h units. So I don't know what h is, but I've moved h units along the right. So my new value is whatever the old x was plus h. So my new x value is x plus h, and when I plug in x plus h, the y value gives f of x plus h. So now my 2 points are x, f of x, and x plus h, f of x plus h. Now if you plug that into the slope formula, look what happens in the denominator. So say that this is y2 minus y1. So f of x plus h minus f of x. Now do x2 minus x1. X plus h minus x leaves us with just an h in the denominator. So we're down to a single variable. Hello? Yes. I did. No, I can bring it. Okay, I'll do that. Bye. Okay, so that's what we're doing. Difference quotient is just the slope formula written very fancily for calculus. So that tells me to find the difference quotient and simplify it. So if I told you that the difference quotient was just a fancy way to find the slope, what do you think you should get as the answer?
The number.
Yeah, what number?
This one.
Yeah, what's the slope here?
1.
No. You can't look at that and tell me what the slope is?
Oh, it's -2.
Yes. F of x equals negative 2x plus 3. That's in slope-intercept form. No, that's why I went to the next problem up there. Okay, so the slope of this is negative 2. So once I get finished with a difference quotient, I expect to get negative 2. Because all it's doing is finding the slope.
What's the point of doing it if you're going to have the slope?
Okay, so we plug this in. F of x plus h. I'm just writing down the formula. Minus f of x all over h. So first, I'm plugging in x plus h for x. So that's going to give me negative 2 times x plus h plus 3. So this is this part. Now I need to subtract all of f of x. So I'm subtracting all of negative 2x plus 3, and then I'm going to divide by h. So now you've got a lot of distributing to do, and make sure you're careful with those negatives. Negative 2 times x is negative 2x. Negative 2 times h is negative 2h. Then you've got a plus 3. Minus negative 2x gives plus 2x. Minus positive 3 gives minus 3. That's all over h.
Like everything possible cancels out.
Now in the numerator, we have like terms. Negative 2x plus 2x goes to 0. 3 minus 3 goes to 0. I'm left with negative 2h in the numerator, and that's being divided by h. So I've got a common factor of h in the numerator and denominator that I can cancel out, and I'm left with negative 2.